atomic thought, or The Law of Vibrant Energy, by William Walker Atkinson. The Paradox of Science. In the days of the ancients, when the philosophers found themselves unable to account for any particular class of phenomena, they bundled it together and referred it to a supposititious something that they called the Ether. Finding this an easy way to get rid of vexatious questions, they fell into the custom, and the habit grew upon them. Soon there were a dozen or more different kind of ethers in vogue, each explaining something else, the something else, by the way, being things that science now feels that it understands pretty well. These ethers grew to be like the various vapors of the ancients, a dignified term for "we don't know," a respectable road for retreat under the semblance of an advance. These ethers became a scientific scandal, and caused a lax mode of thinking among students of those times, and so they were finally abolished and relegated to the scrap pile of science, where they lay for many centuries until a comparatively recent period, when at least one of them was hauled forth, dusted, freshened up a little, and placed upon its old pedestal. This revamped ether referred to was the ether of Aristotle. Aristotle, as we know, was a famous Greek philosopher who lived about 350 B.C., about 2,250 years ago. He was a good man and a celebrated philosopher, but was somewhat deficient in scientific knowledge. Although he knew many things and uttered many wise thoughts, he was under the impression that the breath of man entered the heart instead of the lungs, that the back part of the skull was empty, and so on. He was without the advantages of a modern training, which was not his fault, however. Well, Aristotle conceived the idea of a universal ether, which he thought pervaded all space, and with which he accounted for the passage of light from the sun and stars, the movements of the planets, and various other physical phenomena. It is not known whether Aristotle really believed in this ether, or whether he merely used it as a speculative hypothesis, following the ether habit of his contemporaries. At any rate, his theory served its purpose, lived, flourished, declined, and died, at least seemed to be dead. But its corpse was resurrected in modern times and used to account for diverse things. This does not mean that modern thinkers really believe in the universal ether. They merely assume it as a working hypothesis until something better is offered. Its principal modern use is to account for the transmission of light from the sun and stars to the earth. It was held that a thing could not act where it was not, and so it became necessary to account for the transmission either by the theory that small particles of substance were thrown off from the sun and traveled to the earth, or else that there was some medium of communication by means of vibrations, etc. Newton held to the first theory, but his hypothesis went down before the ether advocates, who advanced the wave theory, although it seems that, like Banquo's ghost, Newton's theory will not stay down, and is now taking on a new lease of life, owing to the discovery of the corpuscle and radiant matter. The wave theory philosophers asserted that the light and heat of the sun were thrown off in the shape of force or energy, and transformed into waves, in and of a hypothetical ether, Aristotle's own, which waves were carried to the earth, where meeting substance they were again transformed into heat and light. It was known that light and heat traveled at the rate of 184,000 miles per second, and therefore the waves of the ether were considered to have that speed. The wave theory seemed to fit the facts of the case better than the Newtonian theory of corpuscles, although the latter has always been considered as better explaining certain phenomena than the new theory, and so the ether wave became generally accepted and remains so today, although recent discoveries are causing a disturbance in the scientific camp regarding the question. Later it was discovered that the electricity traveled at the same rate as light and heat, and the wave of the ether theory was thus thought to have additional verification, and electricity came under the law and remained there until the electron discovery, which is causing much disturbance among those interested in the study of electricity. Briefly stated, the theory of the universal ether is this. that pervading all space in the universe, not only between planets, stars, and suns, but also filling in the cracks between molecules and atoms as well, there is a subtle substance in and through which the waves of light, heat, electricity, and magnetism travel at the rate of 184,000 miles per second. This substance is said to be matter that is not matter. In fact, science does not venture to say just what it is, although it freely states just what some of its properties must be, and alas, these properties are most contradictory and opposite to each other, as we shall see as we proceed. The universal ether is purely hypothetical. It has been called a necessity of science, something assumed for the purpose of explaining or accounting for certain phenomena. It is undemonstrated and unproved. In fact, may truthfully be said to be undemonstratable and unprovable. Some have gone so far as to say that its claimed properties and qualities render it unthinkable as well. And yet, science finds itself compelled to assume that the ether, or something like it, exists, or else cease speculating about it. It belongs to the realm of pure theory, and yet many writers treat it as if it were a positively demonstrated and proven fact. Let us examine into the nature of science's problem and her attempted solution, and the trouble arising therefrom. Light travels at the rate of 184,000 miles a second. Remember that light and heat are that which we call by those names only when considered in connection with substance. According to the theory, light in the sun's atmosphere is transformed into a light wave of the ether on its travels to the earth, and only when the wave comes in contact with the substance on the earth's body or atmosphere does it become again transformed into light as we know it. In its travels through space it meets with no substance, and has nothing to turn into light. Consequently, space, between worlds, is in a state of absolute darkness. The same is true of heat, and inner world space is absolutely cold, although passing through it are countless heat waves of great intensity which, later on, will be transformed into heat when they reach the substance, the earth. The same is true of electricity and magnetism. Although the ether, as we have seen, is a purely theoretical substance, yet science has found it reasonable to conclude that it must be possessed of certain attributes in order to account for certain known facts. Thus, it is said to be frictionless, else the worlds, suns, and planets could not pass freely through it, nor could the light and heat waves travel at such a tremendous rate. It also is thought to have something like inertia, because motion once started in it persists until stopped, because it is at a state of rest until motion is imparted to it, and because it takes a fraction of time to impart motion to it. It is thought to be different from substance in any of its known forms, for many reasons, among such being the fact that no known form of substance could carry vibrations through space at the rate of 184,000 miles a second. And light and heat waves travel at that rate and have forms and shapes and lengths of their own. Light, for instance, vibrates on two planes, and a light wave is something like a Greek cross, thus having a horizontal and a vertical line or plane of vibration. And the ether cannot be a fluid of any degree, because a fluid cannot transmit cross vibrations at all. And it cannot be a solid, because a solid could not stand vibrations at such a terrific speed and still remain a solid. And yet, to transmit the two-plane light waves, the ether must have a certain degree of rigidity, else the waves could not travel. Lord Kelvin estimated this degree of rigidity as about 19/1000th of the rigidity of the hardest steel. So you see, science is compelled to assume that the ether is a continuous, frictionless medium, possessing both inertia and rigidity. Some scientists have thought it to be a kind of elastic jelly. Of the ether, Professor Oliver Lodge has said, "We have to try and realize the idea of a perfectly continuous, subtle, incompressible substance pervading all space, and penetrating between the molecules of ordinary matter, which are embedded in it, and connected to one another by its means, and we must regard it as the one universal medium by which all actions between bodies are carried on. This, then, is its function, to act as the transmitter of motion and energy. To give you an idea of the wonderful thing that science is compelled to think of the ether as being, by reason of the qualities it is compelled to ascribe to it, although it confesses itself unable to imagine the nature of the thing which it has created in bits by the adding and bestowing of qualities which were made necessary by the logical requirements of the case, let us take a hurried view of the thing as the several departments of science say it must be thought of. To meet the requirements of the case, science says that the universal ether must be substance infinitely more rare and evanescent than the finest gas or vapor known to science, even in its rarest condition. It must convey heat in the manner of an infinitely solid body, and yet it must not be a solid. It must be transparent and invisible. It must be frictionless and yet incompressible. It cannot be a fluid. It cannot have attraction for substance, such as all substance has, nor can it have weight, that is, it is not subject to gravitation. It is beyond the reach of any known scientific instrument, even of the greatest power, and it refuses to register itself in any way, either to senses or instruments. It cannot be known of itself, but may only be recognized as existent by the things for which it acts as a medium or transmitting agent. It must convey energy and motion, yet it must not take up any part of either from the matter in its midst. It must not absorb any of the heat, light, or electricity. It must fill up the spaces between the worlds, as well as the most minute space between the molecules, atoms, and corpuscles, or any other minute particle of substance, either known by name to science now, or which may be discovered or imagined later as a necessity of some conception regarding the nature of substance. In short, the universal ether, in order to do the things attributed to it, must be more solid than solids, more vapor-like and gas-like than vapor or gas, more fluid than fluids, infinitely less rigid than steel, and yet infinitely stronger than the strongest steel. It must be a substance having the qualities of a vacuum. It must be continuous and not composed of particles, atoms, or molecules. It must be an everything in some respects, and yet a nothing in others. It must not be substance, and yet it must carry substance within its ocean of dimensions, and besides interpenetrate the most minute space between the particles of substance. It must not be energy or force, and yet science has been considering energy and force as but interruptions of rest or agitations within and of itself. So you see that this mysterious, wonderful, universal ether, in order to be at all, must be a something possessing certain qualities or properties of substance, many of the properties of qualities being exactly contradictory and opposed to each other, and yet it cannot be substance as we know it. It is a paradoxical thing. It could only belong to another and an entirely different order of existence from that of substance as we know it. It must possess characteristics and properties of an order as yet unknown to us by name, for which the material world contains no analogy, for which substance has no analogues. It must be a far more complex thing than is even the most complex thing we call matter, or that which we call force or energy. And yet it has been claimed that it would explain both, yes, contain within itself the possibility of both. And yet, in face of what has just been said, the writer must confess, humbly and with a full realization of the enormity of the offense, that he supposes advancing a theory a little further on in this book that will attempt to identify this something, this universal ether, with a something else that we know, although not through the senses or by means of instruments. Bear with him kindly, he begs of you, while he proceeds gradually along the path that leads to the theory. Scientists have compared substance moving through the ether as a coarse sieve moving through water, the latter making room for the passage of the sieve and then closing up behind it. If this be amended by the idea that the moving sieve, while allowing the water to pass through it freely, still carries along with it a thin film of water which clings to the wires of the sieve by adhesion, if there be admitted this clinging film, as well as the body of the water through which the sieve moves, then the illustration answers quite well as a crude illustration of Substance and the Ether. This fact is important in view of the theory that will be advanced further on in this book. Professor Lodge, in his interesting work, Modern Views of Electricity, mentions a number of experiments tending to prove the above-mentioned fact, which is not so generally known as other facts relating to the ether. Until the discovery of radiant matter, bringing with it the new theories of the corpuscle or electron, etc., brushed aside into the dust heap many generally accepted scientific theories regarding the nature of Substance, the favored and most popular theory was what was known as the vortex ring, the theory of the atom. This theory held that the atoms of Substance were but vortex rings of the ether, having had motion communicated to them in some way, and which afterwards acquired other motions, and which finally become apparent to our senses as substance. In other words, the atom was supposed to be a vortex ring of ether, acted upon by force, in some unknown way, the character, nature, and properties of the atom being determined by the shape and size of the vortex ring, the rate of motion, etc., etc. The new discoveries of science, however, have set aside, at least temporarily, this vortex ring theory, and at present science seems to find its latest thing in Substance, in the theory that Substance, at the last, seems to be the corpuscle or electron. In other words, after many years of fancied security and a settled theory regarding the nature of Substance, science once more finds itself compelled to take up the search for the origin of things. But the theory of the ether remains, and is likely to, although the names applied to it will change. By some it is still believed that in the ether, a little further removed, rests the origin of Substance, and that the corpuscle may be the vortex ring product, instead of the atom. It will be noticed that science has made no serious attempt to connect the phenomenon of gravitation or attraction with the ether. Gravitation stands alone, an outsider among the forces, responding to none of their laws, needing no time in which to travel, needing no medium like the ether in which to transmit waves, fearing no obstacle or interfering body, but passing right through the same, different. And we shall see why this difference when we reach the point where our theory brings us to the point where we must substitute something else for that great paradoxical general solvent of modern science, the ether of Aristotle. We shall reach the point after a brief consideration of motion, force, and energy. End of Chapter 7. Chapter 8 of Dynamic Thought, or The Law of Vibrant Energy, by William Walker Atkinson. The Forces of Nature. The substance filling the universe is in constant and unceasing motion. Motion is evidenced in every physical and chemical process and change, and manifested in the constant interchange of position of the particles of substance. There is absolutely no rest in nature. Everything is constantly changing, moving, and vibrating. Building up processes are ever at work forming larger masses of bodies of the particles, and tearing down processes, disintegration and decomposition of molecules and atoms and corpuscles are constantly at work also. Nature maintains a constant balance among her forces. If the building up energies and forces were allowed full sway, then all the particles in the universe ultimately would gravitate to a common center, thus forming a compact and solid mass, which would thus dwell for eternity unless the creative power should move upon it and again scatter its particles in all directions. And if the tearing down and dispersive forces and energies were allowed full sway, the particles would fly apart and would remain asunder for eternity, unless called together by some new creative fiat. But nature pits one force against another, maintaining an equilibrium. The result is constant play and interplay of forces, causing distribution and redistribution of particles, following the gathering together and building up processes. There is no lost motion or waste force. One form of force and motion is converted into another, and so on and on. Nothing is lost, all force is conserved, as we shall see as we proceed. In the public mind, or rather, in the mind of that part of the public which think of the matter at all, there seems to be an idea that force is something of the nature of an entity, separate from substance or mind, something that pounces down upon substance and drives it along by presence from without. The ancient philosophers regarded substance as acted upon from without by an entity called force, substance being regarded as absolutely inert and dead. This idea, which is still held by the average person, owing, doubtless, to the survival of old forms of expression, was generally held by philosophers until the time of Descartes and Newton. This old idea was due to the teachings of Aristotle, he of the ether theory, and science and philosophy were timid about shaking off the Aristotelian dogmas. Others held that light, heat, and electricity were fluids, conveyed from body to body. In fact, the general public still entertains this idea regarding electricity, owing to the use of the term the electric fluid. The present teaching of science is that force is the result of the motion of the particles of substance, and of course originates from within rather than from without. It is true that motion may be communicated to a body by means of another body in motion, imparting the same to it, but that does not alter the case, for the original motion came from the movement and vibration of the particles of substance, although it may have passed through many stages of transformation, change, and transmission in its progress. The only exception to the rule is gravitation, which is a form of force, the nature of which is unknown to science, although its laws of operation, etc., are understood. We shall learn some new facts about gravitation in the forthcoming chapters of this book. It will be well for us to remember this fact, in our consideration of force and motion, that force and motion originate from the inherent property of motion passed by the particles of substance, and come from within, not from without. This is the best teaching of modern science, and also forms an important part of the theory of dynamic thought, which is advanced in this book. Buckner, the author of Force and Matter, vigorously insists upon this conception, saying, among many other similar expressions, force may be defined as a condition of activity or a motion of matter, or of the minutest particles of matter, or a capacity thereof. The term force is generally defined in works on physics as that which causes, changes, or terminates motion. The word force is generally used in the sense of in action, while energy is usually used in the sense of potential force, capacity for performing work. The idea being that it is stored up force or force awaiting use. The term power is used in two senses, the first meaning a measure of mechanical energy, such as a 40 horsepower engine, etc. The second sense being capacity or ability to act or exercise force. This use being almost identical to the idea of energy as above described, although possibly a little stronger expression. The materialistic school holds that force is a property of matter, the latter being regarded as the real thing of the universe. Others hold that force is the real thing, and that what is called matter or substance is but a center of force, etc. Others hold that the two are but aspects of the same thing, calling the thing by the name matter-force, or force-matter. Haeckel calls the combined thing by the name of substance, claiming that what are called matter and force are but attributes of it, the third attribute being sensation, which he holds is akin to mind. Haeckel's substance is held to be eternal and self-existent, its own cause, in fact. In this book the term substance is not used in this sense, but merely as synonymous with what science usually calls matter. The views advanced in this book differ materially from any of those above mentioned, it being held by the writer that all force is vital mental force, and consequently force, as a separate thing, is considered an unreasonable proposition, what is called force being considered merely an action of mind upon substance, causing motion. The writer does not intend to advance this idea at this point beyond the mere mentioning of the fact, the theory being brought out and developed as we proceed, and he will proceed to a consideration of the phenomena of force along the lines of modern science, believing that in this way the subject may be better understood. The term motion, as used in physics, is defined as the act, process, or state of changing place or position, movement, Webster. So you see, motion is the movement of substance, changing place or position. Force is that which causes, changes, or terminates motion, and energy is the capacity for manifesting force, and power the ability to act. In works on physics you will notice the expression potential energy, meaning energy awaiting action, also kinetic energy, meaning energy in action, that is, in motion. We shall not need these terms in this book, but it is well to understand them. Another term frequently met with is conservation of energy, which is used to indicate the law of physics, the operation of which renders energy indestructible. That is, science holds that energy cannot be destroyed, that it is not lost or created, but is merely transformed into other forms of energy, potential or kinetic. Therefore, after energy is used, it either passes into a state of potential energy or rest, awaiting a future call to activity, or else is immediately transformed into another form of kinetic energy, or energy in action. The theory holds that the quantity or amount of energy in the universe is fixed in its totality. None may be created or destroyed. There can be no addition to or subtraction from the totality of energy, that all energy used has been previously stored up, or else has been immediately transmitted or transformed. It is also held that when energy manifests as the result of work performed, it is always found that it is at the expense of some previously manifested form of energy, that the agency by which the work is performed always parts with its stock of energy, and that the thing worked upon always acquires or gains the amount of energy lost by the aforesaid agent, or worker, and yet there is no actual loss or gain, but merely transformation. The above theory is mentioned as of interest in the general subject, although it does not play a prominent part in the subject of this book, for the writer holds that all energy resides in mind, and emerges therefrom, and in the end returns thereto. This being believed, it is seen that energy is not to be thought of as a separate thing having a totality, but merely as a quality of mind. The question of its totality or fixed quantity not being inquired into, although both probably run along the lines of the nature of mind, and depend upon the limitations or lack of limitations of the latter. However, the question does not assume a vital importance in our consideration of the subject. So far as the question of transmission or transformation of energy is concerned, however, the principles of the law of conservation of energy may be accepted as correct, although it more properly belongs to the principle of what has been called the correlation of force, the idea of which is that one form of energy may be, and is always, transformed into another form, and so on, unto infinity. This idea is followed in this book, except that the idea of from mind originally to mind finally is incorporated within it. This law of the correlation of force may be illustrated by the following quotation from Tyndall, the great scientist of the last century, who says: "A river, in descending from an elevation of 7,720 feet, generates an amount of heat competent to augment its own temperature 10 degrees Fahrenheit, and this amount of heat was abstracted from the sun in order to lift the matter of the river to the elevation from which it falls. As long as the river continues on the heights, Whether in the solid form or as a glacier, or in the liquid form as a lake, the heat expended by the sun in lifting it has disappeared from the universe. It has been consumed in the act of lifting. But, at the moment that the river starts upon its downward course and encounters the resistance of its bed, the heat expanded in its elevation begins to be restored. The mental eye, indeed, can follow the emission from its source through the ether, as vibratory motion, to the ocean, where it ceases to be vibration and takes the potential form among the molecules of aqueous vapor, to the mountain top, where the heat absorbed in vaporization is given out in condensation, while that expended by the sun in lifting the water to its present elevation is still unrestored. This we find paid back to the last unit by the friction along the river's bed, at the bottom of the cascade, where the plunge of the torrent is suddenly arrested, in the warmth of the machinery turned by the river, in the spark from the millstone, beneath the crusher of the miner, in the alpine sawmill, in the milk churn of the chalet, in the supports of the cradle in which the mountaineer, by water power, rocks his baby to sleep. All the forms of mechanical motion here indicated are simply the parceling out of an amount of calorific motion derived originally from the sun, and at each point at which the mechanical motion is destroyed or diminished, it is the sun's heat which is restored. The following quotation also is interesting as illustrating another phase of this law. The work performed by men and other animals is due to the transformed energy of food. This food is of vegetable origin and owes its energy to the solar rays. The energy of men and animals is, therefore, the transformed energy of the sun. Excepting the energy of the tides, the sun's rays are the source of all the forms of energy practically available. It has been estimated that the heat received by the earth from the sun each year would melt a layer of ice over the entire globe 100 feet in thickness. This represents energy equal to 1 horsepower for each 50 square feet of surface. Anthony and Brackett. From the above quotations, it will be seen that the principal and most familiar sources, or great storage batteries, of energy apparent to dwellers upon this planet are 1. The earth manifesting the power of gravitation, and 2. The sun manifesting solar heat. In Tyndall's illustration we see the force of the sun's energy, heat, raising the water from the ocean, by evaporation, although aided by the earth's gravitation, pulling down the heavier air, allowing the vapor to rise. Then we see the force of gravitation causes the condensed vapor to fall as rain or snow on the mountain top, then causing the rain to run into little streams, and so on until the river is reached, then causing the river to start on its downward journey of over 7,000 feet, then causing it to plunge over the cascade, to turn the wheels that operated the machinery, and turned the millstone, and the crusher of the miner, and the sawmill, and the milk churn, and the cradle. And as Tyndall might have added, had he lived a little later, in the running of the dynamo, which running produced electricity, that in turn caused lights to burn, other machinery to run, and manufacture things, stoves to cook, flat irons to iron, automobiles and engines to run, and many other things along the lines of transmitting energy, force, and motion. And in this consideration, let us not forget the important part that gravitation, that most wonderful of all forces, plays in the grand scheme of nature. Not only does this force cause the planets to circle around the sun, and perhaps that sun around another sun, and so on until the matter becomes unthinkable. Not only this, but it performs 1,000,000 parts in the affair of earthly matter, as we shall see in a later chapter. The force of gravitation is one of the greatest mysteries confronting science today, although many believe it a simple question. Gravitation and the universal ether contain the great secrets of nature that man is striving to unveil. And yet so common is gravitation that the race, including almost all the scientists, take it as a matter of course. We shall devote much attention to the question of gravitation in the forthcoming chapters of this book, for it plays a very important part in the general theory of dynamic thought, upon which this book is based. We shall have a special chapter devoted to it a little later on, and the matter will also come up for explanation further on in the book. But in the meantime, let us consider the other forms of energy, viz., heat, light, magnetism, and electricity, which with gravitation and attraction of other kinds form the forces of nature. End of Chapter 8. Chapter 9. Of Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. Radiant Energy. The kinds of energy are very few, although the methods of using, applying, and manifesting same are innumerable. Let us begin with one of the best known forms of energy, namely heat. Heat was formerly regarded as a very fine fluid or substance called caloric, which was supposed to enter into substance and then manifest the phenomenon of heat. This idea has long been relegated to the scrap pile of science. The present theory, which is supported by a mass of evidence obtained through investigation and experimentation, is that heat is a form of energy arising from the vibratory motions of the particles of substance, a mode of motion. The degrees of heat are termed temperature. Temperature depends upon the rate of the heat vibrations of the particles of substance, either arising from the original motion of the particles, or else from vibrations or motion aroused in them by transmission from particles of other bodies of substance, these vibrations being contagious. Temperature then means the measure of the vibrations of the particles. All bodies of substance have some degree of temperature, some degree of heat vibration of its particles. Science has a pleasant scientific friction of an absolute zero at the degree of 491 below zero, Fahrenheit. But this is merely an imaginary something with which the grown-up children of science amuse themselves. When two bodies are brought near each other, the nearness being comparative, and in some cases meaning a distance of millions of miles, heat is transmitted from the warmer to the cooler body, until the temperatures are equalized. That is until the two bodies vibrate in unison. In physics we are taught that the transmission of heat may be accomplished in three ways, although the writer is of the opinion that the three ways are but three forms of one way. The first form is called conduction, whereby the vibration or heat is conveyed along a body of substance, from its warmer to its cooler parts, for instance, an iron poker with one end in the fire. The second form is called convection, whereby the visible motion of heated substance moving along the air, for instance, hot air, hot water, steam, etc., either by means of pipes or by allowing them to pass freely through the air. The third form is called radiation, whereby the vibrations are believed to be transformed into waves of the ether, which will be spoken of later, in addition to what has been said on the subject in our chapter entitled The Paradox of Science. The writer thinks that a little consideration will show us that the same rule operates in all of the above cases, and that conduction and convection are but forms of radiation. For instance, in conduction there must be a few particles first set into vibration, the same gradually passing on to the others farther and farther away. Passing how? By contact, replies physics. But the particles are never in absolute contact. There always is plenty of space between them, and so there must be some kind of waves passing through the space between them, which space is not filled with air or other form of substance, but only with the ether or something that takes its place. So that, after all, conduction is but a form of radiation, and the same rule will apply in the case of convection. Heat arises from several causes, all of which, however, manifest through the vibration of the particles of the body evidencing the heat. These causes may be stated as 1. Original motion of the particles of a body of substance, arising from some workings of the law of attraction, and including motion arising from chemical action, combustion, etc. 2. From transmission or contagion from some other body of substance, the particles of which are vibrating at the rate of heat. 3. From interrupted motion, including friction, both of the moving body with the air or other substance, and the friction of a current or electricity passing through the body. In each of the above cases, the actual and immediate cause of the heat is the vibration of the particles of the substance manifesting the heat, although the transmitted vibratory waves, or the interrupted motion, friction, current, etc., may have been the instigator or provoker of such vibration. The interrupted motion, friction, or wave does not produce the heat, but merely arouses or provokes the increased vibration of the particles that really manifest the heat. At the least, remember, the heat is in the particles of the body that feels or experiences it. The vibrations of heat seem to have the properties of causing the molecules to draw further apart and to manifest less attraction or more repulsion, whichever way one cares to express it. This moving away of the molecules tends to cause the body to increase in volume or size, and occasions what is known as expansion in substance. In this way, heat transforms solids into liquids, liquids into gases or vapors, the change being wholly a matter of the relative distances of the molecules. Magnetism is another form of energy, and is generally believed to be a part of the phenomena of electricity, if indeed not a form of electricity itself. Science knows very little about the nature of magnetism, but in a general way holds to the theory that it results from the vibration or motion of the particles of substance, as do all other forms of energy. The magnetic qualities of a body may be increased or decreased by motion affecting the relation of the molecules, which fact has been regarded as having some bearing on the theory. Electricity is a form of energy that science regards as also arising from the vibration or motion of the particles of substance. It is transmitted like heat, by conduction and radiation, the waves tending to provoke similar vibrations in the particles of substances receiving them. By many careful investigators, electricity is believed to be very closely related to the phenomenon called light, both having much in common. Science seems to be discovering new points of resemblance between them, and it is possible that in the near future they will be seen to be but varying forms of the same thing. The purposes of this book do not call for an extended consideration of the properties of electricity, the same being served by a consideration of its nature being akin to that of the other forms of energy, namely, vibration or motion in or among the particles of matter. Light is a form of energy, the study of which is of the greatest interest to science, for the reason that the field seems to be widening out continuously, and reaching out into the territory formerly thought to be the special region of electricity. And in another direction, it seems to be reaching out into the territory of heat, the latter being considered by many to be but a form of light, in its lower vibrations. In fact, the writer of this book so considers the subject, and for the purposes of this book, in latter chapters he will combine electricity, heat, and light, including also the phenomena known as the X-rays, Becquerel rays, radium waves, etc., as forms of light, the combined forms of energy to be called radiant energy. In this combination he believes that he is in line with the latest and best thought of modern science. However, he does not insist upon his readers following this idea, and so, if they prefer, they may think of each of these forms as separate and distinct, and yet not run contrary to the line of thought of the book. Light is not the simple thing that it is considered to be by the general public. It is composed of many parts, qualities, and manifestations. Its rays, when separated by the spectrum, are seen to consist of waves or vibrations of differing degrees of rate and intensity. The lower range contains the heat rays, and it is interesting to know that there are rays of heat too far down in the scale to be evidenced by human senses that may be distinguished by delicate instruments. But there are rays still further down in the scale that are known to exist, theoretically, that cannot be registered even by the finest instruments. To gain an idea of the delicacy of these instruments, let us remember that Professor Langley has an instrument called the bolometer that is so delicate that it registers a change of temperature of 1/1,000,000th of a degree, and will register the heat of a candle 1 1/2 miles distance from it. Light vibrations arise from combustion, friction, electricity, etc., causing the particles to assume increased motion. Let us consider the report of the spectrum. Beginning with waves or vibrations far below the sensibility of man, the scale shows an advance until the first "warm" vibration of iron was reached. This first indication of warmth comes when the vibrations reach the rate of 35 trillion per second. Then gradually they increase until a dull red glow is noticed, the lowest visible light ray, when the vibrations are 450 trillion per second. Then come the orange rays, then the golden yellow, then the pure yellow, then the greenish yellow, then the pure green, then the greenish blue, then the ocean blue, then the cyanic blue, then the indigo, then the violet, the latter evidencing when the vibrations reach the rate of 750 trillion per second. Then come the ultraviolet rays, invisible to human sight, but evidenced by chemical media. In this ultraviolet region lies the X-rays, etc., and also the actinic rays that produce photographs, sunburn one's face and blister the nose, that cause violent explosions in chemicals that transform forms of substance that are employed to cure skin diseases, etc. These actinate or chemical rays have an important role to play in plant life, for they act upon the green leaves of the plant, causing a chemical change by which carbonic acid and water are transformed into sugar and starches. Some of the rays of the ultraviolet region of light penetrate substances formerly considered solid and impenetrable, and some of them, emitted from radium, etc., would destroy organic life if applied in sufficient quantities. Some of them are practically waves of electricity, so that light and electricity are seen to be closely related. To give one an idea of the differences produced by different rates of vibration, let us imagine a mass of iron shaped like a great top, capable of being impelled to spin at a constantly increasing rate of speed by some mighty will. At first it is seen as a slowly spinning top, manifesting nothing but slow motion to our senses. Now imagine our top spinning at a rate doubling each second. The first second the top spins at the rate of 2 revolutions per second. We notice no change except that we can see the movement. The next second the revolutions are doubled to 4 per second. Then, doubling each second, we have, respectively, revolutions of 8 per second, then 16, and then in the 5th second, 32 per second. Then we begin to notice a change. When the revolutions reach 32 per second, the friction of the moving top on the air causes it to give forth a very low, deep bass note of sound. This note is like a low, deep hum, and is the lowest possible of perception by the human hearing, although it is possible that some of the lower forms of life may be conscious of still lower vibrations. The 6th second the revolutions reach 64, and the low note has grown much higher in the scale. The 7th second records a rate of 128, and the note has correspondingly increased. Then, as the seconds pass, we have successively 256, 512, 1024, 2048, 4096, 8192, 16,384, 32,768, the latter in the 15th second, and representing the highest note recognizable by the human ear, although it is believed that some of the lower animals may recognize sounds too acute for our sense of hearing. During this increase in revolutions from the 5th second to the 15th, the sound note has risen rapidly in the scale from the low sullen hum on through the notes of the musical scale and beyond the range of instruments, until the shrillness becomes so intense as to be almost unbearable, and finally terminating in a shrill, piercing shriek like the squeak of the bat, only long drawn out. Then, from the termination of the sound, by reason of the rate of vibration having become too high, silence reigns for 30 seconds. Absolute silence, in spite of the rapidly increasing rate of vibrations, in fact, because of it. When the 45th second is reached, and the revolutions have reached the rate of 35,184,372,088,832 per second, our top begins to emit heat rays increasing each second. Then a little later a dull, dim glow may be noticed. Then, As the seconds fly, the dull glow manifests a deep dark red color, such as one notices in the iron of the blacksmith's shop soon after it begins to glow. Then, on and on, as the seconds fly, the deep red grows lighter and brighter, gradually changing into orange, then into yellow, then into green, then into blue, then into indigo, then into violet, and then into the color of white heat. Then this white heat changes into a still more dazzling white, and then a white impossible to describe appears, so bright, clear and brilliant that the eye cannot bear the sight. Then suddenly the intense brightness is succeeded by absolute darkness, and the moving top cannot be seen by the eye, and yet it moves on. The highest recorded chemical rays of light are estimated to equal a rate of vibration of 1,875,000,000,000,000 per second. The vibration of the lowest shade of red light is estimated at 450 trillion, and the highest of violet at 750 trillion per second. So we may imagine what the highest line on the spectrum is like. Still vibrating, our top, which has become now a mass of vaporized iron, rapidly tending toward still more ethereal forms, it has passed out from the region of light waves into another unknown region of vibrations, in which region, however, exist the vibrations known to us as the X-rays, etc. It is throwing off great quantities of electrons. If we were to use a fluorescent screen, we would be able to observe the phenomena of the Röntgen rays and similar manifestations of radiant energy. On and on vibrates the top of what we once called iron, cold iron, warm iron, hot iron, melted iron, gaseous iron, etherealized iron, if you like. What it is like now, the imagination of man cannot conceive. Still the revolutions continue, doubling each second. What is being produced? The imagination cannot conceive of what this state of substance, now being reached, is like. By a scientific form of poetry we might think of it as melting into energy, pure energy, if there were such a thing. Long since it has been resolved into its original particles, its corpuscles, and perhaps into the stuff from which particles are made. But we must let the curtain drop. The wildest fancy cannot follow the dance of substance any further. The theory of the transmission of vibrations of radiant energy by means of waves in the ether, or something that takes the place of the ether, has been mentioned in other parts of the book. Referring again to it, the writer would say that he thinks it's probable that the waves, coming in contact with the countless corpuscles in the Earth's atmosphere, communicate a high rate of motion to them, the result being that they take on the vibrations immediately and pass along with the wave current. The result being that much that we consider as waves of light, heat, and electricity are but streams of these corpuscles in which vibrations have been awakened by the waves. This idea will help to explain some of the phenomena of light which seemed more understandable under the old light corpuscle theory of Newton than under the wave theory of recent years. The idea is advanced merely for the purpose of setting down the thought, for it plays no important part in the theory of the book. Another matter that should not be overlooked in connection with light and heat and electricity is that particles absorb or catch the vibrations in different degrees, their receptivity depending upon their particular vibratory mode or custom of their kind. If unable to absorb the vibrations, they reflect them. Substance of any particular kind absorb heat in the degree of its atomic weight. In the next chapter we shall learn something of the law of attraction, that wonderful law that makes possible any motion or radiant energy. End of Chapter 9.